Welcome to MEI Numerical Methods Introduction. In this video we'll be looking at using calculators and spreadsheets. In this example we're going to find the square root of 2 approximately using a calculator, and we're going to start with this rectangle up here which has got an area of 2, and eventually it's going to turn into a square also of area 2, and the sides are then going to be the square root of 2. But supposing for the moment we don't know what the square root of 2 is, and we think it's about 1.5. So if we make one of the sides 1.5, then the other side will be 2 divided by 1.5, which is 1.3 recurring. And as our next estimate, we're going to take the average of 1.5 and 1.3 recurring, because clearly if we want to make the rectangle into a square, we're going to have to reduce the 1.5 and increase the 1.3 recurring. So we take the average, and that gives us 1.416 recurring, which is getting closer to the square root of 2. And if one of the sides is 1.416 recurring, the other side, as before, will be 2 divided by that number, which gives us 1.41176. So the sides are both getting quite close now, and in general we would apply this formula. So this is an example of a recurrence relation. So for the rth value we would take the average of the r minus first value and the other side that was produced by that. So that average then, that gives us our new value. And notice that we started on x0. That's fairly standard to do that. And you might like to have a go at this yourself on a calculator. Now these instructions are based on a Casio calculator, but it will probably be something fairly similar on other models. So the idea is you have to first of all get the calculator to know what the initial value of the answer is, and so we're putting in 1.5, so going 1.5 equals, and then if you press the all clear button, if you wanted to, you could then, if you then were to press the answer button, that would reveal 1.5, but we want to get rid of the 1.5 so we can start with a fresh formula. So we then type in effectively the recurrence relation with using ants instead of x r minus 1. So if we type in that formula, and then all we need to do is then just press equals again and again, and you'll need to press the button that converts it into the answer into a decimal. So you might like to have a go at that. Pause the video and have a go at that now, and you should get these values. So 1.414213, that is accurate to 7 decimal places. Now here we have an example of using a spreadsheet. I ought to mention here that this is an Excel spreadsheet, and when you work out the sign of something in Excel, then the angle needs to be in radians, which you should have come across in complex numbers, but if you haven't for some reason, then it's something you're going to cover later on in the course. And the thing to remember is that 2 pi radians is the same thing as 360 degrees, and everything else is proportional. So we'll be using spreadsheets later on in the course, and this is an example. In fact, we'll be looking at this particular slide later on, and we're looking at values of h that get progressively smaller, and for each value of h we can establish what we're interested in. This expression here, sine 1 plus h minus sine 1 over h. And if we go to the next slide, we can see we've got the cursor on the cell B4, and you only need to type in equals. I think it introduces a plus sign automatically. But so the formula is really sine. So we've got sine of 1 plus A4. We've got a dollar symbol here. That's can be useful if you're copying a formula to, and if you were to copy this formula to, for example, to column D, then it would maintain the A. So you always want that, if you always want that formula to refer to column A where the H's are, then you'd have the dollar symbol. If you didn't have the dollar symbol, then it will always refer to the previous column. So if you were to transfer it to column E, then it would refer to whatever was in column D. But we don't need to do the same. In fact, we don't want to do the same thing for the rows, because when we want to copy this formula down to the rows below, and we want those rows to, we want the row below to refer to A5, which is the 0.01 there. And then we've got a similar formula in the next column, in column C. Okay, so that was a brief introduction to using calculators and spreadsheets, and in the next video we'll be looking at errors and rounding part 1.